Hello friends, welcome to EK lectures. In this lecture we are discussing the stability factor for a transistor.
Stability factor S is defined as how independent our operating point. See, a basic idea of all the biasing conditions. See, we had all biasing conditions. Now, what is our basic idea of this biasing condition? This basic idea is simply to understand or to make the system or the circuit independent or more stable. That means one value when you take even after the temperature increases or heating in the circuit increases, we should get a stable output. That is what our aim is. Now, uh, so to understand how independent is our operating point or how stable our, you can write how stable is our operating point with respect to transistor parameters. Transistor parameters like alpha, beta, and gamma. Then forward current, the diode, this transistor resistance, etc. And also on the external temperature. Okay, so now this is how it is done. Now, what is it actually telling me? It is the rate of change of IC. Rate of change of IC, that means collector current with respect to IC naught. IC naught is what? That is nothing but reverse current or reverse saturation current. This is happening due to minority charge carriers. So small current, but this will tell you how fast or whether our circuit is having a better stability or not. Now, what is that? S is equal to rate of change of IC with respect to DIC naught. Now, for a common emitter uh, biasing condition, we have IC or IE equal to IC plus IB, right? IC plus IB, and IC we can write it as alpha times IE plus IC naught. Alpha IE plus IC naught. IC we can write it as alpha IE plus IC naught. Alpha is current amplification factor in common base. Now, what is this IE? IE again we can write it in this way, IC plus IB. So alpha into IC plus IB plus IC naught. Now what you can do is bring this quantity to the left side. So IC into 1 minus alpha equal to alpha times IB plus IC naught. Now divide this quantity by 1 minus alpha. If you divide, what you are getting? IC is equal to alpha divided by 1 minus alpha plus 1 divided by 1 minus alpha into IC naught. And what is this? Alpha divided by 1 minus alpha. IB is also there. That is nothing but beta. Beta IB plus, and 1 divided by 1 minus alpha is nothing but beta plus 1. Beta plus 1 IC naught. So IC equal to beta IB plus beta plus 1 IC naught. What you have? IC equal to beta IB plus beta plus 1 into IC naught. Right? Now with respect to IC, differentiating with respect to IC. This one with respect to IC, what you get? 1. 1 is equal to beta into DIB by DIC plus beta plus 1 into DIC naught divided by DIC. Am I correct? Now 1 is equal to, writing this first quantity as it is, DIB by DIC plus beta plus 1 into, and what is this quantity? DIC naught divided by DIC. DIC divided by DIC naught is equal to our stability factor S. Correct? So this is beta plus 1 into 1 by S. Now this is stability factor. Now we want stability factor. Yes. So this we can write it as 1 minus beta into DIB by DIC equal to beta plus 1 into 1 by S. Now S is equal to, bring this term to the right side, beta plus 1 divided by 1 minus beta into DIB by DIC. So this is the stability factor formula. Please remember, questions have come. IB is equal to VCC minus VBE divided by RB, right? And what is IC? IC is nothing but beta times IB, so that will be equal to beta into VCC minus VBE divided by RB. That's it. Now this is now applying to output. VCC equal to ICRC plus VCE. There is no voltage drop across RE. So what you know? So you can write what is VCE, not required, but still. VCE equal to VCC minus IC into RC. Alright. Now let us go to input side. VCC equal to IBRB plus VCE, right? Now just differentiate with respect to IC. What you are getting? 0, this quantity 0, differentiating with respect to IC, 0 equal to DIB by DIC into RB. RB is a constant, plus, sorry, not, this is not VCE, this is VB. IBRB plus VB. Okay, that quantity is 0. Now you can write this, what is DIB by DIC plus 0. This means DIB by DIC is equal to 0. So you got this one. Now we can write stability factor S is equal to Yeah, stability factor S is equal to beta plus 1 divided by 1 minus beta into dIB by DIC. Now dIB by DIC is equal to 0. This particular quantity equal to 0. So a stability factor S is equal to beta plus 1. So this is the stability factor for fixed bias, beta plus 1. So input, what is input? VCC IBRB plus VBE plus IERE. Now this IE we can write it as IC plus IB into RE. Now differentiate with respect to IC. Okay. Now this quantity will be 0 equal to IB and RB. So DIB divided by DIC into RB plus VB, that is quantity will be again 0 plus DI DIB by DIC plus 1 into RE. With respect to IC we are differentiating. Alright, and this quantity what you can do is split it and make it once again we will write 0 is equal to DIB by DIC into RB plus RE plus RE. I hope you are getting it. So this particular quantity DIB by DIC is equal to minus RE divided by RB plus RE. Now stability factor S is equal to 1 plus beta divided by 1 minus beta into DIB by DIC. So what is that? So 1 plus beta into 1 minus beta into minus RE divided by RB plus RE. So minus and minus get becomes plus. So this quantity is 1 plus beta divided by 1 plus beta into RE divided by RB plus RE. Please make a note of it. So once again VCC is equal to, here through this current is I, and this will be IB, this is IC. So RC into IB plus IC plus IB into RB, IB into RB to the input side plus VB. Now differentiating with respect to IC, what you are getting is RC into DIB plus DIC plus 1 plus DIB by DIC into RB. Now once we got this, what we want is DIB by DIC. Take these 2 points. So that is equal to DIB by DIC into RC plus RB plus RC. So DIB by DIC is equal to minus RC divided by RC plus RB. Now we have the stability factor equation. S is equal to 1 plus beta divided by 1 minus beta into DIB by DIC. Just substitute this DIB by DIC in this equation. So what you are getting is 1 plus beta divided by 1 plus beta into RC divided by RC plus RB. Now you see in the previous case what you got is RE divided by RB plus RE, that is for emitter bias. Emitter bias means resistance through emitter. It depends on RE. Now you have got collector feedback. It depends on RC. VTH is equal to this RTH into IB you can write. Okay, this is the current flowing through base. TH into IB plus here you have VBE again plus IE into RE. This IE you can convert to IC plus RE. So what you have, VTH is equal to RTH into IB plus VBE plus IC plus IB into RE. Alright. Now differentiate with respect to IC. What you have? This is 0. So RTH into DIB by DIC plus this quantity again 0. RE into 1 plus DIB by DIC. Correct? Yeah. Again, what you want? DIB by DIC. So DIB by DIC is equal to minus RTH divided by minus this one RE minus RE divided by RTH plus R. Now our stability factor S is equal to 1 plus beta divided by 1 minus beta into DIB by DIC. Just substitute this value 1 plus beta divided by 1 minus, this minus and minus will get cancelled, RE divided by RTH plus RE. So that is it for